Okay, so next we are going to learn about two special operations that we can do on matrices. And these are called the matrix transpose and the matrix Hermitian conjugate. So let's first look at the transpose of a matrix. Okay, so suppose you have a matrix A. The way to denote that you want to calculate the transpose of matrix A is to say add a little capital T as a superscript to the matrix. Okay, so that's the transpose of matrix T. And what this means is you swap rows with columns. That's simply what it is. So for example, if you have a matrix which is equal to this one, yeah, this is a matrix. This is a 2 by 3 matrix. So if you do the transpose of matrix A, so then the first row becomes the first column, 3, 1, 2, while the second row becomes the second column, A, 0, pi. And that would be the transpose of matrix A. One way of remembering how to do the transpose of a matrix is to imagine that you have a mirror. So you have a mirror that you place going through the elements of the main diagonal of a matrix. So the first top element, then the second row, second column, and so on. You do a mirror along that line. Yeah. So then this mirror means that, for example, this element 1 is reflected on the mirror and then that ends up there. So that's where it ends up. While the element A is swapped with the 1. Yeah, so that's what you see here. The elements on the main diagonal stay where they are. The 3 and the 0, they stay where they are. And then this 2 is reflected to the other side, so ends up there. And this pi is reflected and ends up there. Yeah. So the trick of the mirror is always is the handy way to remember what the transpose is. Now the transpose has properties. So, for example, if you scale a matrix by a scalar, lambda times A, and you transpose the result, you can take the scalar away. Yeah, so this is like lambda multiplied by A transposed. Also, interestingly, if you have the multiplication of two matrices, B times A, so you multiply them together, and the result, you transpose it, and be careful with this. This is equal to A transpose multiplied by B transpose. So beware, because they have been swapped. So whenever you transpose the product of matrices, you cannot just apply the transpose to each one, you have to swap the order. Okay, remember that property. Good. Next we can do this definition of what a symmetric matrix is. So a matrix A is symmetric if and only if A equals A transpose. And how does a symmetric matrix look like? Well, it looks like simply a matrix that has this mirror symmetry. So if we have, for example, matrix A, let me write a symmetric matrix. So we can have 0, 1, 0, pi. And then if we have an A here, we also have an A here. If we have a 2 here, we also have a 2 here. If we have a square root of 2 here, we have a square root of 2 here. Yeah. So A is equal to A transpose. So what happens is that if you draw this diagonal, then whatever is on one side of the mirror is copied on the other side. Yeah. So that's a symmetric matrix. Another interesting thing we can do with the transpose is to write the dot product between two vectors as if it was a matrix operation. So have a look at this. The dot product of A dot B, that would be the first element of A multiplied by the first element of A plus the second element of B multiplied by the second element of B plus dot dot dot, yeah? So this can be written as A transposed matrix multiplied with B. Okay? So how is this possible? Okay, let me write it in elements form. Okay, let's assume we are in three-dimensional space. So we could say that A dot B is equal to a vector A dot a vector B. And we are writing vectors as columns, yeah? And this is equal to AX BX plus AY BY plus AZ BZ. Okay, but at the same time, what if we do A transpose matrix multiplication B? So this would mean, so let's imagine that now this vector A, we imagine that this vector A, instead of being a vector, it's actually a 3 times 1 matrix because it has 3 rows and 1 column. So what would A transpose be? If we imagine this vector A to be a matrix, the transpose is simply converting the first column into the first row. Yeah. So this becomes a matrix which is AX, AY, AZ. This would be A transpose, and this is a 1 times 3 matrix. And now we do the matrix multiplication with this other matrix, Bx, By, Bz. These two matrices can be multiplied because it's a 1 times 3 matrix multiplied by a 3 times 1 matrix. And the result is a 1 times 1 matrix, which is equal Ax times Bx plus Ay times By plus Az times Bz as a 1 times 1 matrix. So that is a scalar. Okay, so this is nice because it means that scalars can be imagined as being 1 times 1 matrices, and vectors can be imagined as being matrices with only 1 column, and still we can do operations with them. Yeah. So the dot product between two vectors becomes this transpose trick here. Okay. So we will often use this in proofs that involve dot products. Okay. Example. Problem 23. Find the transpose of matrix A given here. So if A is equal to 3, 1, 2, 0, 4, 1, A transpose is equal to, so either you start thinking that the first row becomes the first column and the second row becomes the second column, or you imagine the mirror. Either way, what you get is the matrix, this one. So that's the transpose of a matrix. Thanks for watching.